The joy in the team when we first heard the message that the other aircraft was detected, that was a major milestone. So Project Rescue really underpins the mission and the vision, the objectives for ARCA. So ARCA is all about aerospace automation, and in particular guided by the integration of unmanned aircraft in civilian airspace.
The key thing we'd like to see them used is in places like precision agriculture or search and rescue applications. And so Rescue itself was put together to basically bring the technologies required to allow that civilian integration to occur as fast as possible. And we've been able to successfully detect on board a Scan Eagle of an oncoming Cessna. And that's a really big step for us. That's a major milestone.
There are a lot of organisations trying to get the answer solved for UAV detect and avoid, and this is one of the leading ones. Scan Eagle is a small UAV at about 20 kilograms. It's launched by a pneumatic powered catapult. It's basically operated from a ground control station remotely. It recovers by capturing a vertical rope on a skyhook.
In a project like this, you really need to have a big thinking end user like the state government to provide the applications that we want to drive to. We need to have a commercial partner like In Situ Pacific or Boeing that provide the technical know-how and also the commercial experience to deliver those applications. We've taken ideas that researchers have had and we've demonstrated them over time, and now we're working really hard to commercialise them and get them over to industry.
So the key innovations in this technology relate to the algorithms inside the system and the way in which the information received, the sensor and images are processed to determine if the target is present. You do the design about how the algorithm should be designed, and then you go and fly it, and it's this amazing feeling.
The aim of this project has been to take the system that we've previously demonstrated in Smart Skies on board a Cessna and migrate that to a Scan Eagle.
Essentially we fly directly towards the Scan Eagle. And the see and avoid payload that's fitted to the Scan Eagle is attempting to detect us before we get too close.
So when it detects something which is on a collision course, it'll send a warning down through a wireless downlink to this ground control station. Further development of the system is going to have this fully automated and a closed loop where it'll detect another aircraft and it will, by itself, it'll manoeuvre the aircraft out of the way.
But this data processing is actually done by a graphical processor unit, a GPU. Which is a technology found in video cards which are designed for gaming. So everybody wants to be able to play Angry Birds on their phones really fast, and we're using that same sort of technology to bring the size, weight and power down of the see and avoid sensor to enable it to fly on small UAVs.
I was involved in similar projects working with research and production centers in Russia, and I also spent 6 months working with German colleagues, but in Australia it's the most advanced.
Projects like Project Rescue and this research centre here at ARCA, I think there are lots of opportunities and exciting activities that we engage in terms of students within researchers. We get out there and we fly things.